Hey, we're going to start on 6.1, exponential growth and decay functions. How many remember growth and decay from algebra? Okay, whatever you remember about a growth and decay function, tell your neighbor right now. Maybe with a picture, equation. Hey, if I could have your attention back up here. That's sad. Need everyone's attention up here, please. Hey, that means you're done talking. Thank you. So on page 164 or 154, I want you to apply some of those things you talked about, hopefully to help you match up those graphs with the appropriate function. I do not want you to use a graphing calculator. Okay? So leave that aside for now. You shouldn't need a calculator. Do your best to match those graphs with the appropriate function. All right? You work together. All right. Can I have your attention, please? Man, it's a tough day today. Hey, guys, within 5 seconds of me asking, please. Hey, seriously. I shouldn't have to ask more than once. I want it within 5 seconds. You guys can do that. Okay? Letter A. Which graph? A. Letter A goes with A? Okay. How come? All right, raise your hand. Jacob, what do you got? So you just said when x is 1, you get 2. You did that for all those. Okay. So that works with A. So with B, when x is 1, you get 3. So that would match up with F. Okay. So f of x equals 3 to the power of x. Still blurry. Okay. Does that work with letter C? Okay, letter C goes with graph. Which one? Okay. Okay, what type of graphs are those? Those are growth graphs, right? They're rising from left to right. Okay, so growth graphs go up from left to right. Might be something to put into your notes if you didn't remember that. Decay graphs go down from left to right. Okay, so if you're kind of summarizing that, you may summarize it a bit on next page anyway. How about on letter D, E, and F? Those are a little tougher. If I put 1 in, I get 1/2 out. How do I mean, that's... You put in -1?
Yeah.
Okay, if I put in -1, that gives me what? 2, yeah. So, good. So if I put -1 in here, I get 2 out. You flip it. Okay? And so that means if I go to -1, 2, that's actually graph D. Okay? Which is f of x equals 1/2 to the x power. Okay? That denominator, as long as the numerator is 1 on top, the denominator is right there. Okay? That works on B as well. Okay, this has a 3 there, so that would be f of x equals 1/3 x. Or 1/3 to the power of x. Notice you got to put it in parentheses because you're raising both top and bottom to the power of x. And this would be f of x equals, it's like we're at 4 there, so 1/4. Okay, very good. Hopefully you learned something about plugging in 1 and -1 as well to help out. I want you to take a look at the next page. It gives you the opportunity to summarize some of that. Okay? Before you do that, I want you to determine the domain and range, the y-intercept of the graph f of x equals b to the x, where b is a positive number. Use these graphs to help you out. Okay, once you think you have a general idea, apply it to these graphs and see if you're correct. And then make sure you answer questions 3 and 4 about the characteristics of exponential function. Talk about growth. Okay? Talk about decay. Talk about the form y equals b to the power of x. What happens if b is a fraction? Okay? And then make sure you answer question 4 as well. Give you guys some time to do that. Okay. Hey, let's summarize these here. Domain. hopefully we got all real numbers. The graph has no holes or asymptotes and no stopping points. Now, we haven't talked about either of those things, about holes or asymptotes or stopping points, but just so we know, that maybe the other way to think about that is the graph keeps expanding horizontally, right? So when we're talking about domain, we're talking about the x values. If you have a graph, so whether the graph looks like this or if the graph looks like this, it doesn't stop expanding horizontally. Therefore, it's all real numbers. The range, however, y has to be greater. The graph approaches but never actually touches the x-axis. Therefore, we're going to have a range of y is greater than 0. Our y-intercept is when x is 0. In this case, our y-intercept on all of these is 1. Okay, when we put 0 in for x, we get 1 out. All right, and if we looked at all of our graphs, we'd have seen that too. Okay, number 3, the graph has an x-axis as an asymptote. An asymptote is just a line that it approaches but never crosses. Okay? Huh? Yep, we call it an asymptote. There is no restriction on the domain. Growth picture looks like this. A decay picture looks like that. Growth function would be y equals bx, where b has to be greater than what? True? So growth happens when b is greater than 1. Decay happens when b is good. B has to be less than 1, but it has to be greater than 0. Okay, so in other words, it's in between 1 and 0. It's a fraction, one of those fractionals. Okay, remember b happened to also be when x equals 1. B is, or excuse me, y equals, when x equals 1, y equals what? Y equals b. Okay? Should have used pencil. Y equals b. And that's what we saw on our original graphs. You may also want to talk about, if you have that fractional, then the bottom number is what y equals when it's a negative. Okay, when it's -1. No, you can't have it hit the x-axis because that would mean the y value is 0. So if I took this and plugged in 0 right here, there's no way for a function to ever get to 0 or an exponent to ever get to 0. It's not possible. Okay. You can get infinitely close to 0. Get very, 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 we could put a big negative number like a -1000 right here. But you're never going to get to 0. That would give you 1 over b to 1000. A really huge number on bottom and a 1 on top. However, you're going to be extremely close to 0, but not actually be at 0. Okay? It's like me saying, hey, I'm going to walk halfway to the door for the rest of my life. I never will leave the room. That's sad. I feel like I never leave the room right now, but it is sad. Okay? All right. I know you don't. All right. Any questions? That's it for today. We'll pick up there tomorrow.